Arcs and Chords is the title of our Chapter 10, Section 3, Arcs and Chords. Okay, you should be familiar with those two words at this point. So we want to be able to recognize and use relationships between arcs and chords, as well as recognize and use relationships between chords and diameters. Remember, we learned that a diameter is a special kind of chord. So some new words that you will encounter will be like inscribed and circumscribed and that kind of good thing. Okay, so let's look at some chord theorems here. The first one says in the same circle or congruent circles, because they'd be the same size, right? Two minor arcs are congruent if and only if. So here we learned that if and only if thing in the last video. It was a if with two F's. Whoops. If and only if. This is the same thing. It means the only way that could happen. Okay, so two minor arcs are congruent if and only if their corresponding chords are congruent. So let's think about that again. Two minor arcs. Remember, an arc is a part of a circle like this. They would be the same length only if their corresponding chords are congruent. Well, we haven't talked about chords and arcs. We've only talked about central angles and arcs. So here's what chords creating arcs would look like. We have this circle, circle A. Remember, a chord begins and ends on the circle. So this would be chord DE. Those are the endpoints. And it also cuts an arc off of that circle. And the arc name is DE. It's just that one would be written with a line segment over it. That would be your chord. The other one would be written with an arc symbol over it. That is your arc. Okay, same endpoints though, so they have kind of the same name, just a different symbol associated with them. Okay, so according to this theorem, these two arcs, DE and BC, will only be congruent if these two chords are congruent. Now remember, this is in the same circle, or the same size circle. And that kind of makes sense. You know, if I take a pie or a pizza and I make the exact same cut across that circle, I'm going to get the same amount of pizza there. Okay, so the arcs will be congruent if the chords are congruent. And vice versa. The chords are congruent, the arcs will be congruent. Okay, inscribed polygons. Inscribed, to scribe, to scribble, means to draw, to write. The prefix in means inside. So this means we have written or drawn or scribbled a polygon inside a circle. Okay, if all the vertices of a polygon lie on the circle, okay, vertices is plural for vertex, remember. So that would mean all the points, let's just draw a triangle because that would be easy to draw. All the points of the triangle would lie on the circle, okay? Or a square. Here's my circle. All the points of the square would have to lie on the circle. Okay? Then it is inscribed in the circle because the polygon is inside the circle. But where is the circle with respect to the polygon? It is outside. It is being drawn around. Drawn around. So we say that the circle is circumscribed. This prefix circum means around. We learned that with circumcenter. Circumcircle. Circumference. All comes from the same root word. So here's an example of a regular hexagon. Okay, you gotta remember what all these words mean. Regular means all angles are congruent and all sides are congruent. Can't forget that. sides. Hexagon. How many sides is a hexagon? 6. Can't forget this stuff. Is inscribed in a circle as part of a logo for an advertisement. If opposite vertices are connected by line segments, so here we've taken this vertex and we've connected the opposite one with a line segment, okay? And then we took this vertex and the one opposite straight across from the triangle, and we connected it, and then we connected this one over here on the left to this one on the right. So if opposite vertices are connected by line segments, what is the measure of angle P in degrees? Well, what we basically did was draw 3 different diameters. So we chopped that circle up into 6 congruent pieces. I'll just call this 1, 2, 3, 4, 5, 6. And they're all equal pieces. Well, if I drew the arcs on each one of these pieces, I would be making a what? I just created a circle which has how many degrees? Has 360 degrees. If I have 6 even pieces, each piece would be 60 degrees. Okay? So since connecting the opposite vertices of a regular hexagon divides it into 6 congruent triangles or pieces, each central angle will be congruent, and the measure of each angle is 360 divided by 6. A logo for an advertising campaign is a pentagon. Penta meaning 5. You got to know these prefixes. So it has 5 congruent central angles. Determine if arc PTS, this big arc here, is congruent to PAS. Okay, well, PTS involves these 2 angles. They're all congruent, right? So if it has 2 angles as its central angle here, and PAS has 1, 2, 3 angles included in its central angle, are they going to be congruent to each other? No, because 2 angles is going to be less than the 3 angles. So the answer is going to be no. Okay, here's another chord theorem. Remember, a diameter is a chord. If a diameter of a circle is, what does this symbol mean? Perpendicular. If the diameter of a circle is perpendicular to a chord, then the diameter bisects the chord and its arc. So what does that look like? I know these words don't mean anything to many until they see a picture. So here's a diameter. If this diameter is perpendicular to the chord, then it is bisecting the chord. That means these 2 parts are congruent, and its arc. These 2 arc lengths are congruent. So now I can set up all kinds of problems asking to find unknowns. Okay, so AD, this section, is going to be congruent to DC and our 2 arcs. We can write congruency statements. Arc AB is congruent to arc BC. So let's use that here. We have circle W. Has a radius of 10. Okay, radius of 10. So I'm going to write that in here. I may not use it, but I might. So this is 10. Radius WL is perpendicular to chord HK. So I know because they're perpendicular, there's a right angle there. According to the rule we just learned, HJ is going to be congruent to JK. KL is going to be congruent to HL. Let's put 2 double congruency marks there to clarify. Okay, so it's perpendicular to HK, which is 16 centimeters long. This whole thing is 16 centimeters. If HL is 53, find the measure of arc MK. Okay. Well, if this is 53, I know this is 53. If ML is a diameter, I know that from M all the way through K to L, this whole distance here is a semicircle, which is 180. Well, if this part is 53, how am I going to find this other part over here? I'm just going to subtract. And I get 127. Okay, so here it is all written out. Since radius WL is perpendicular, then I know that arc HL is congruent to LK, which I already marked. Together, those two arcs equal 180, so when I subtract them, I get 127. Let's do another one. Circle W has a radius of 10. Okay. Radius WL is perpendicular, which is 16. Okay, so all the same information from the last time. This is 16. This time I want to find, just JL right here. Okay, well, I know the whole thing is 10, right? But nothing tells me that WL is being cut in half. Nothing is telling me that WL is being cut in half. So how are we going to solve this? I can create a right triangle. Let me get all my markings out of the way here. Okay. I can create a right triangle here because I have a right angle. And I want to do it here because I know that this is a radius. And if one radius is 10, they're all 10. So I know this green line here that I just created is 10. What else do I know? I know that if this whole thing, HK, is 16, then the radius here, WL, is going to cut it in half, so this portion is 8. Now I have a right triangle that we can pull out, if it helps you to see it better. How much is this WJ portion going to be? Well, this is a Pythagorean triple. This is 4 times 2, and this is 5 times 2. So this is going to be 3 times 2, which is 6. X equals 6. Now, is that my answer? It's asking for JL, this part. How much was the whole thing? WL, if it's a radius, it's 10. 10 minus 6 is 4. So JL equals 4. Okay, so using lots of relationships, lots of rules. It's all about putting it all together, problem solving. That's what this class is all about. Okay, here's another one. Circle O has a radius of 25, so I know that this distance from here to here is 25. Radius OC is perpendicular to chord AB, so I automatically know AH is congruent to HB, arc AC is congruent to arc CB. Write it in. And AB is 40 units long, so I know this is going to be 20 and this is going to be 20. If MG right here is 35, find CBG. Okay. Well, I really don't even need to know all this information because I know that this is a radius. So this whole big arc here is a semicircle, which equals 180. If this portion is 35 and I'm looking for the other portion, I'm just going to do 180 minus that 35. So I had lots of what's called extraneous information, information I did not need. You got to know how to sift through it and determine what you need and what you don't need. Okay, so this relationship went back to the last video on semicircles. Didn't even need to know all this other stuff that we just learned. Deciphering important information. Okay, circle O has a radius of 25. Same thing, but this time we are looking for CH. We're looking for this radius. I'm sorry. No, we're not. Let me erase that. We're looking for part of that radius. Do you remember how we did that in the last problem? We're just looking for CH here. We need to draw in our hypotenuse. This is a right triangle. See if we can find this radius, because that's the same as this radius, and then subtract our leg from it. Okay, so if I know this radius is 25, I know that these two portions of AB are 20 and 20, because the whole thing's 40, and it's going to be bisected by this perpendicular radius. I can now find x by doing a squared plus b squared equals c squared. Look for these Pythagorean triples. I see that 20 is 4 times 5, and I see that 25 is 5 times 5. So this is going to be 3 times 5. I'm multiplying my Pythagorean triple, my 3, 4, 5 triangle, by the same number. So this is going to be 15. X is 15. If the whole thing is 25, just like this radius, OB is 25, OC is going to be 25, and this portion's 15, then the portion we're looking for has to be 10. Okay, some more chord theorems. In the same circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. Oh, that word, we keep coming across it. Same distance. Okay, so it's going to look something like this. Here's our center. We have two chords. If they are the same distance from that center, so EG is congruent to EF, then CD is going to be congruent to AB. And so will their chords, or their arcs. The chords and the arcs both will be congruent to each other. If and only if what? If and only if they are equidistant from the center. So let's do some problems with that, and then we'll be finished. Okay, so EF and GH are equidistant, so I know these two distances are the same. If the radius of circle P is 15, EF is 24, so I know it's bisected because those are perpendicular. Find PR and RH. Okay, well, this situation and this situation are all going to be the same because everything's equal. So that means this is 12 and this is 12. Right? And I want to find PR. Okay, so again, I need to make my right triangle here. They told me the radius is 15. Is this a Pythagorean triple? I'm multiplying here 5 times 3. Here is 4 times 3. So this one's going to be 3 times 3, which is 9. So PR is 9. And RH is 12. PR equals 9. RH equals 12. So just go in there and mark up everything that you know. Start finding all these distances, and hopefully within that you will find your answer. Let me erase all my markings, because I have it done all nice and neat. I get carried away with my pen sometimes. So there's my radius, it's 15. I know EF is 24. So GH is 24. Each part is 12. Again, it's a Pythagorean triple. You could go through Pythagorean triple working it all out. A squared plus B squared equals C squared. That's what I've done over here. But if you recognize those triples, it saves you so much work. Either way, we get 9. So we plug that in. So that answers the PR question and the HR question. Okay, if SZ and UV are equidistant, so I know these two symbols or segments are the same. If TX, so let's find TX, is 39, okay, what part of the circle is TX? If it starts from the center and goes to the edge, it is a diameter. And XY is 15. Find WZ. What does this over here have to do with this over here? Remember, they're the same. They mirror each other if they're equidistant. So here's a radius. I can draw a radius just like it over here to create a right triangle. Now here we don't have a Pythagorean triple. So we're going to have to do a squared plus x squared equals c squared. This is a 39. Whatever x ends up being, that's what WZ is going to be. So I'm going to let you work through that. I'll set you up. 15 squared plus x squared equals 39 squared. Pause the video, work through that, and see what answer you get. Hopefully you paused it and worked it out yourself, and you saw that our missing side was 36. Right, so if UY is 36, then YV is 36, because those are congruent. And they are also congruent to SW and WZ. So when you find one, you find all four. Okay, I think you get the idea, so we'll stop there. Again, we're running kind of long. But just remember to make those right triangles. Okay, I'll leave this one for you to work out. Make right triangles where you need to, just drawing in a radius, and use Pythagorean theorem. Okay, so stop the video, practice this one, see if you can do it on your own. Hopefully you stopped it, did it on your own. I'll give you the right answer, 72. So you know what your answer should be. See if you can figure out how to get there. Here's another one. If AD and DC equal these two things, what are you going to do to solve? What do we do to congruent parts? We set them equal to each other. If AB is 4y plus 8 and AEC is 96 degrees right here, okay, if this central angle is 96 degrees, then so is this arc that it makes, but we only want half of it. So 4y plus 8 is going to equal half of 96, which is 48. Okay, work it out. Pause the video and do your own work and see if you can get it. Okay. So here's how you'd set it up, but hopefully you did it yourself. So you should have gotten x equals 2, y equals 10. Takes practice, 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 guys. If you're not willing to practice, then you're not going to succeed. Okay, joke time. What's a cow's favorite painting? Famous painting that a cow would like. The Mona Lisa. Ha ha ha. Have a good one. We're done.